Let us continue with the adaptive multi-layer networks which we have studied. Now we have first had a look at the network pruning algorithms, the different techniques of pruning. Now we shall have a look at the network growing algorithms. Now, network growing algorithms, there are several algorithms that would be used to build larger networks beginning from small ones. So you start with a network which is very small, and then depending upon the application, depending upon the task which is required to be performed, every time you will go on adding certain nodes to this neural network, and you will be adding layers, you will be adding neurons in a particular layer such that it will be it can be called as an adaptive network. So that is the reason it is called as these algorithms are called as network growing algorithms. There are three algorithms: Marchand's algorithm, then we have the neural tree algorithm, and then we have the tiling algorithm. There is one more algorithm as well which is called as the upstart algorithm, which is not included. So we shall have a look at the first algorithm, which is Marchand's. Now in Marchand's algorithm, what happens is, so it is a training algorithm for a feed-forward network with one hidden layer. So we know what is a feed-forward network. So this what I have drawn here, you can consider it as a feed-forward network wherein the weights, when there is one hidden layer, and you can see that the connection of the weights. So you can see these weights. There is one hidden layer which will be present here. There is one hidden layer which will be present here, and hence this is a feed-forward network with one hidden layer. Okay, it is not a feedback network, it is feed-forward because there is no feedback which is connected from the output to the input. So it is a simple feed-forward network. So Marchand's algorithm will be used in order to basically design a feed-forward network with one hidden layer. Now each node will be computing a step function. So if at all you consider every node, at every node it will be computing a step function. So basically the output can be either 0 or 1. Okay, if at all it is bipolar, it will be either +1 or -1. So each node will be computing a step function. Now the hidden nodes are successively added to the network such that the k+1th hidden node performs some non-redundant classification over and above what has been performed by the first k hidden nodes. So in this case, what we shall be basically doing is that we would be going on adding hidden nodes. So now in this particular network there is one hidden node. So this is the first hidden node which is added, then second node, then the third hidden node. Like this you will be going on adding hidden nodes. So basically the first step would be to get one hidden node. So we will be getting a neural network with one hidden node. So if at all I see x1, x2 and a bias 1. So this is the first hidden node, and then every time I will go on adding hidden nodes. So this is the second hidden node. So this second hidden node which I add has to perform the classification which was not done by the first hidden node. So it cannot, so that is some non-redundant classification over and above what has been performed. So now you have, so first node is doing some classification, second node is doing some classification. I add a third node such that this third node will perform the classification which was not done by the first and the second node. So every time you add a node, it will be performing some non-redundant classification. So that is what is the important technique here. So every node, whichever is added, has to perform some classification task. Now I have shown some patterns in the pattern space, and if at all I want to perform the classification of these patterns. Now there are patterns from two different classes. So this can be say class 1 and this can be class 2. So what happens is that I would be having a neuron which would be performing this classification. A neuron which is having a step function will be giving nothing but okay, it will be representing a line. Okay, so I can use a line to classify. So you can see here, this side of the line we have patterns from class 2 and this side we have patterns from class 1. So basically what we have done is that, I'm not saying that this side we have patterns of class 1, but also we have, okay, it is basically a mixture of patterns. We have class 1 definitely here, but there is class 2 as well. So whenever I am drawing this line, that is the first line which I have drawn here, this line, it will give me the classification of these patterns which are here, and on the other side it would be the patterns which are still remaining unclassified. So now if at all I go further, I can do the second step. And so first step, I have had a neural network which would be giving me something like this. Okay, and then at the second step what I do is that I take one more neuron in order to classify the other part. If at all I have to draw a line, maybe I can draw a line here. So this is the line which I draw here, and for which I get another neuron. So now this line, whichever I have drawn here, has done extra classification what was not done by this line. The first line which you selected was not able to do this classification, so now I have done this. So using the second neuron, so I have another neuron gets added to the network. Then if at all I go further, now if at all you see here, completely the patterns are classified. So this side I can say pattern of class 2, this pattern is of class 1 and this pattern is again of class 2. So my task is done. But if at all there were some more patterns which needed to be classified, okay, and there were some patterns here, then maybe I still have to draw one more line such that these patterns also get classified. So one more node has to be added. So basically it is step by step addition of the nodes in a neural network. That is what is done in this particular algorithm, that is the Marchand's algorithm. Now let Tk plus and Tk minus represent the training samples of the two classes that remain to be correctly classified at the kth iteration. Now, so this is the pattern which is given to you. Now all these patterns which I am indicating, these patterns and these patterns will belong to, say, the class Tk plus. So this is one particular class, and then there is one more class which is there, which is of these patterns. So I can indicate these patterns as Tk minus. Whichever one you can want, you can name it Tk plus. With the other one you will have to name it as Tk minus. So what happens is that now it is not Tk plus and it is not Tk minus. What is K here? Actually in this particular case K is equal to 0 because I am just beginning my classification problem. Okay, so K is equal to 0 in this particular case. Every time I perform the classification task, now what did I do first? I took a line and I drew a line here. Yes, I drew a line here. Now after this line, what happened was that these patterns were classified, and so my T0 naught which was there got reduced. Now what is now? T0 naught will become now T0 plus will become T1 plus, and T0 minus will become T1 minus. So what is T1 minus now? After the first classification, whatever patterns are remaining to be classified, that will be T1 minus. So T1 minus will be this. Okay, the patterns of this class are still remaining. And what will be T1 plus? T1 plus will be this, whatever is not yet classified. So basically, next what I will be doing is that, so whatever I have already classified, I will just erase it off to clear the confusion. Next what I will be doing is that I will be drawing one more line here where I had drawn a line here. Now which patterns are getting classified? these patterns are getting classified. So if at all you see, all these patterns are classified and this still remains unclassified. So now I will get a new set, that is T2 plus, and I will get T2 minus. So every time, now what will be T2 plus and T2 minus? T2 plus will be this and this will be T2 minus out of what is left to be classified. Okay, and what will happen is that this will go, because this is already classified, so all these patterns will go. Okay, and then now out of whatever patterns are left, I am drawing one more line here such a way that it will be classified. So I am assuming that these patterns will get classified and it will go. So what will happen is that I will be getting now T3 plus, and here I will be getting T3 minus. So what is T3 plus? T3 plus will become 0 because this full set is gone now. So T3 plus will become 0. There are no patterns in the class of all circles. So basically what I get is that one of the class will become empty. So this Marchand's algorithm, it will be continuing till I am going on reducing these classes. So I begin with T0 plus and T0 minus. These are the two classes, two sets which will be having the training samples, and one by one I am going on reducing. Now at every step either T0 plus will change or T0 minus will change, or I can say in the first step you cannot change both. Any one of them will get changed in every step. Okay, and hence what I can say is that at the last step finally what will happen is that one of them will become empty. So at each iteration node weights are trained such that either, okay, this I have already told you, either tk plus 1, tk1 plus tk1 plus, okay, so this is indicated as tk plus 1 plus is less than tk plus, or the other one. So every time what I told you is that, see, first we began with some patterns, okay, and then some of these patterns will get classified. So if at all I draw a line here, if at all how was that class which I had drawn? Somewhat like this it was. So if I draw a line here, these patterns will get, okay, they are already classified. So at every step tk plus 1 will be less than tk plus. So initially if at all you saw, there were 1, 2, 3, 4, 5, 6, 7, 8 circles which were there. But after the step 1 you are left with only 4 circles. So at each step they will get reduced. At the second step what happened is that the axes will get reduced. All these axes are classified, so the axes will get reduced. But the number of zeros or the circles will remain the same. So at every step, now these tk plus, when I mean to say plus, meaning they are patterns from one class. When I mean to say minus, they are the patterns from the other class. So either one of the patterns will get reduced at every step. So either one of the patterns will get reduced at every step, and this is whatever patterns are left from both the classes. If you see, what is tk plus 1 minus is nothing but the patterns from the class minus which are left at the step k plus 1. See, please note that here we are indicating the two classes as class 1, we say class plus, and class 2 is say minus, meaning any notation you can use, whichever class you want can be named as class, plus class and minus class. So basically what this step tells us is that whatever you get at the next step will always be a subset of what you had at the previous step. So at every next step you are going on reducing the number of samples which are yet to be classified. Fine. Now, and finally the algorithm terminates eventually at the mth step, when finally any one of the set will become a null set or an empty set, which I have indicated to you previously. Now, there are certain things, once this algorithm has been executed until termination, at every step, what I told you is that at every step, what we were doing is that we were going on adding hidden nodes, right? So, if at all I consider the same example, somewhat like this was the example which I had taken. So, I drew a line first here. I drew the first line here. Okay. So, for which I got one hidden node. Then I drew a second line here, for which I got a second hidden node. Then I got a third line here, for which I got the third hidden node. Now, if at all you see, the first, now these are the patterns from say class 1 and these are the patterns from say class 2. Okay. Or so class 1 I can name it as class plus, and this is minus class, and this is also class 2, so it is minus. So the first line, yellow color line which I have drawn here, is classifying patterns from which class? Class 1. The second is classifying from class minus, and the third is classifying from class plus. Okay. So what happens is that at the end of the problem, you will be having a set of two hidden nodes, two sets of hidden nodes. One is a set of all the hidden nodes which are classifying into class plus, and other will be the set of the hidden nodes which are classifying into class minus. So the weights of these hidden nodes, now a new output unit is chosen with a connection from each of these nodes. So all these nodes, whatever are there, all these nodes finally will be connected to a main output node, and the weights of these are connected or selected in such a way that there is an equation which is used to select these weights, and that equation is this. So what this equation says is that omega k meaning it will be omega k. So if at all I want omega 1, it will be omega 1. So for the first one, it will be omega 1. It will be 1 upon 2 raised to k. Now, this node is nothing but the first node. So k will be equal to 1. So I have to replace this k with 1, 2 raised to 1. And what should be the sign? The sign is either plus or it is minus, depending upon whether it belongs to H plus or H minus. So this belongs to H plus, so the sign would be plus. Similarly, omega 2, the second weight for the, so this will be omega 1, this will be omega 2, this will be omega 3. So what will be omega 3? Omega 3, the class is minus class, and it is omega 2, meaning it is the second node. Second node meaning it will be 1 upon 2 raised to 2, and with a minus sign, because it is classifying the pattern, it is classifying into a class of minus. It's classifying the patterns into the minus class. And then the third weight will be omega 3. It is going to indicate the way it is going to separate. It is going to classify the patterns from plus class. So it will be this. So you need to know how to select the weights from the hidden layer to the output layer. Now you already know how to select the weights from the input layer to the hidden layer. That is depending upon the equations of the line. And this technique is used to identify the weights from the hidden layer to the output layer. Now the above weights assignment scheme ensures that the higher weight is given to the earlier generated nodes. So we have seen previously the first generated node, the weight is half is 0.5. Second node, it is minus 1 upon 2 raised to 2, so it is minus 0.25, so it is lesser weightage. So the higher weight is given to the node which is selected first, so that you have to take a note of. Now we shall be solving Marchand's algorithm problems using the same technique, whatever we have seen now.